Hello friends, in today's session we will be solving 3 problems from Electrodynamics from Physics 2020 examination. First question, a charge q moving with uniform speed enters a cylindrical region in free space at t equal to 0 and exits the region at t equal to τ. Which one of the following options best describes the time dependence of the total electric flux through the entire surface of the cylinder? What comes to your mind when you hear the term total flux associated with a surface? The Gauss's law, right? The Gauss's law in electrodynamics is given as del dot T equal to rho by epsilon 0. Its other form is phi equal to q by epsilon 0. Phi is the total flux associated with a Gaussian surface and q is the total charge enclosed. The position of the charge q is not taken into consideration when we calculate the flux. Even when the charge is at the left side or the right side or at the middle, the total flux associated with a Gaussian surface is same, which is q by epsilon 0. So in our case, the charge is moving through the cylinder first, then leaving the cylindrical region to the outer world. When the charge is within the cylinder, the total flux associated with this Gaussian closed surface is q by epsilon 0, and at t equal to τ, the charge leaves this cylindrical region. Then after that the flux will be 0. So our curve should be like this. From 0 to τ time the flux is constant, which is q by epsilon 0, and after time t equal to τ, flux is 0. So the curve is like this. Option D is the right answer. Second question, far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength 4 into 10 raised to 14 ampere meter. Assume this magnetic field is generated by a current carrying loop encircling the magnetic equator. The current required to do so is about 4 into 10 raised to n ampere, where n is an integer. The value of n is dash. Earth's circumference can be approximated as 4 into 10 raised to 7 meter. So let's find out the meaning of the term pole strength. The relation between pole strength and magnetic moment is given by magnetic moment equal to pole strength into length of the bar magnet. If Earth is assumed as a bar magnet, its length will be 2r, the diameter of the Earth. So the magnetic moment associated with the Earth will be the pole strength 4 into 10 raised to 14 into 2r. The tricky part in this question is understanding the term pole strength and finding the magnetic moment of Earth from the pole strength value. Now let us find the equation for the magnetic field due to a current carrying loop. It is given as B equal to mu 0 I r square by 2 into x square plus r square whole raised to 3 by 2. This is a basic equation from 12th standard NCERT. We assume that x is very much greater than r because in the question it is specified that the point is very far from the Earth. In the denominator, if we assume x is very much greater than r, we can neglect capital R with respect to x. So the magnetic field equation can be approximated as mu 0 I r square by 2x cube. So this is the magnetic field produced if a current carrying loop I is placed like this. At a point x from the loop, the magnetic field will have this value. Similarly, the magnetic field due to a bar magnet of magnetic moment m is given by B equal to mu 0 by 4 pi 2m by x cube. X is the distance. Here I have understood taken an axial point. If it is an equatorial point, 2m should be replaced by m. Since we are considering axial points, let us take this equation. Now I am going to equate these two equations because the question asks to find a scenario when these are equal. So mu 0 I r square by 2x cube, the field due to a current carrying loop is equal to the axial field due to a bar magnet. From these two equations, equating these two equations, I will get the value of current as 2m by 2 pi r square. many of the terms cancelled out and I just rearranged the term to get this equation. Now substituting for m, 4 into 10 raised to 14 into 2r was taken as m. We will get 2 into 4 into 10 raised to 14 into 2r by 2 pi r square as I. Now I am going to simplify this. 2 into 2r is taken as 4r into 4 into 10 raised to 14 divided by, I am going to split this 2 pi r square as r into 2 pi r. This 4r and r will cancel and we will get a 4. 2 pi r is the circumference. So I can substitute as 4 into 10 raised to 7. That is why I did not substitute for r yet. It will cancel out here. 4 into 10 raised to 7 and the value of pole strength 4 into 10 raised to 14 will cancel out. So the final value for current is 4 into 10 raised to 7 ampere. Now the question asks to find the value of n, which is the order of this equation, order of this final answer, which is 7. Now the third question. A conducting sphere of radius 1 meter is placed in air. The maximum number of electrons that can be put on the sphere to avoid electrical breakdown is about 7 into 10 raised to n, where n is an integer. The value of n is, assume breakdown electric field strength in air is E equal to 3 into 10 raised to 6. So what should we do here? We should equate the total electric field due to a charged sphere with this critical value, right? So I am going to do that. The electric field due to a uniformly charged sphere is given by 1 by 4 pi epsilon 0 q by r square. Now this q is due to the deposited electrons. If n is the total number of electrons on the surface, total charge of the sphere is Ne. This is the equation for the electric field due to the charged sphere. The electric field should be less than the critical value, which is 3 into 10 raised to 6. Now equating these two values, I will get 1 by 4 pi epsilon 0 Ne by r square equal to 3 into 10 raised to 6. Now all I need is to solve this to find the value of n. 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. It is very good if you study constant value like this because that will make your calculation simple. So 9 into 10 raised to 9 into Ne equal to 3 into 10 raised to 6. Now finding out the value of n by solving this, we will get 2.1 into 10 raised to 15. The question asks to find the value of n, which is the power of 10, which is 15 in this case. I got the value 2.1 in this case. In the question it is given as 7. But solving like this we will be getting 2.1. If anyone is getting 7 as the final answer through any other methods, please let me know in the comment section. Hope you understood today's problems. Thank you.